Assalamualaikum and good evening. So today we would like to present about our image processing project, which is image processing using discrete cosine transform DCT method, and we are from group 12. So this is our group members. First one is Tineswaran Chandran, second is me, Danial, Zaki, Fauzi. Third is Mohamad, Akmal, Paul, Winston, George, Pevinder Kaur, and Alia, Huda, Binti, Bakar. So for the introduction, with the growth of technology and entrance into digital age, the world has found itself amid a vast amount of information. Image compression is the method of using particular encoding schemes to encode digital image information using fewer bits than an encoded representation would use. JPEG is one of the most widely used image compression technique. The discrete cosine transform, which is DCT, is used in JPEG image compression standard. It is a fast transformation and it is also common and reliable image compression tool. Compressing an image is significantly different than compressing raw binary data, and DCT has been widely used in signal processing of image. The one-dimensional DCT is useful in processing one-dimensional signals such as speech waveform. So for the problem statement, nowadays, with higher resolution camera and image capturing device, the image quality is better than before. High resolution image look great as it has better sharpness, definition, and more detail on the image. But this denser resolution picture are big in size as they store more information on them, and bigger size picture are generally harder to handle as they will take more time and more computing power to process. These images are also required bigger storage space to store them, and last one is more computing power and internet data is required to load the process this enormous size image. And we move on to objective. So the objective of this system is to achieve several goals. First one is to design a lossless compression using method discrete cosine transform DCT. Second is to create and develop a lossless compression using MATLAB software. And last one is to test a lossless compression by using different kind of image file format.
Moving on to scope, this image compressing system that will be developed for this project will be using MATLAB as the main software. This system only has one interface. User can insert photo that they want to compress. Size of the photo will be displayed. And once compressed, the compressed photo size will be displayed. This system is to help users that might need to save their device memory space or to user that need to reduce the photo size for them to edit it or upload it. This system uses English as the primary language. Okay, this is the flowchart of the system. Okay, first it will display the main interface. So once it displays the interface, the user need to insert the image. Once the user insert the image, it will read image data with the size of the image. Okay, then user has an optional to compress the image. If the user is already select the image, the system will perform auto image compression. Or if the user don't want to compress the image yet, the user can insert a new image, then only perform the auto image compression DCT. So once it compress the image, it will display a new image. The new image it will compress the image, but will not compress the resolution or the quality of the image. Okay. Once it displays the new image, it will automatically save image to the gallery. Okay. If the user want to compress a new image, the user need to insert a new image and repeat the process. If the user doesn't want to compress a new image, user can just end the system. For project significance, The significance of this project is to apply the discrete cosine transform (DCT) method in forming lossless compression. The importance of this project is to use MATLAB software in developing lossless compression and to test lossless compression using various types of image file format such as PNG, JPEG, TIFF, TIFF, and other format as well.
Okay, next we moving on to expected result. MATLAB is a powerful tool for analyzing image and signal for developing applications. The main reason why we develop this application is to reduce the size of image, which can improve the loading speed and the overall performance of a website. The discrete cosine transform DCT algorithm is used which compresses the image with a good compression ratio. It will display the home page of the lossless image compression. There are two buttons with a select image button, image to be compressed, and compression image button, which is image after being compressed. Next, first must select the image and then click the compress image button to compress. And the last one, the result output will show the original image size and the compressed image size in kilobyte. Okay, next is the literature review for image compression. Image compression is the operation of encoding in digital image information using less bit than an unencoded representation will need using certain encoding algorithm. Lossless compression is a technique for shrinking the size of a file while preserving the same quality as before. Some of the popular image compression methods are fractal, wavelet, chroma subsampling, transform coding, and run-line encoding. There are two types of image compression method, which are lossy compression and lossless compression. Lossless compression is achieved by removing unwanted metadata from JPEG and PNG file. Lossless image compression technique reduces the size even smaller than lossless, but discards some part of the photo, and this process is irreversible. JPEG and GIF are lossy image format. Next, direct cosine transformation (DCT). Direct cosine transform (DCT) is widely used transformation technique used in signal processing and data compression. DCT is used to map an image space into a frequency. DCT-based image compression depends on two methods to reduce the size of an image with quantization and entropy coding. The DCT has the features that most of the visually important information about a picture is contained in only a few coefficients of the DCT for a typical image. There are two methods to compute DCT, which are DCT2 function and DCT transform method.
So I will explain on the comparative analysis. Here we will compare our system with three other systems, which is the image Optim, OptiPNG, and JStrips. For the compression types, all the four systems use lossless. Supported format for image Optim is JPEG, PNG, and GIF. For the OptiPNG, the supported format is BMP, GIF, TIFF, PNG, and PNM. For JStrips, the supported format is JPEG, and for our system's lossless image compression is JPEG, TIFF, BMP, and PNG. For all the four systems, because it's free, the image quality for image Optim is excellent, for the OptiPNG is great, and for the both JStrips and lossless image compression, the image quality is best. The platform supported for image Optim is Mac, while the other three OptiPNG, JStrips, and lossless image compression is for Windows.
Okay, so now I'll present the MATLAB code used to develop our system. So the first code is to create the graphical user interface. On my left hand side is the code used to create the interface of this application. Okay, so this is the image selection code. So this code is for the image selection button. So once user select on this image, users will be given option to select image from formats such as BMP, JPEG, PNG, and TIFF. Images other than this format will not be selected. Okay, so this is the image compression using discrete cosine transform DCT code. This code will be used for the second button, which is the compress image button. Okay, so this is the code to save the image automatically to save the image after compression. So after compression, the image will be saved in JPG form in the folder.
For discussion and conclusion, this project is a lossless image compression using discrete cosine transformation method. This project can compress the image without degrading the quality of the image. It can compress various kinds of image such as JPG, PNG, TIFF, and DMP. This project is designed to by MATLAB software. There are a few functions that should be highlighted during developing lossless image compression project. For example, function var argout, the function push button 1 callback with arguments h objects, event data, and handles.
Okay, for now the framework part, as the code is explained in chapter 3, now we're moving on to the actual framework in MATLAB software. Okay, so for this, this is the our framework in MATLAB software. We'll press run here. So the application will run, and the output will be this interface that we design using the software encode and guide. So from here, there are two columns. The first column will be image compression, select image and compress image. The second column will be size of the uncompressed image and size of the compressed image. So we have to select this button here, select image. So once we press, so it will direct us to the folder. So as we can see, we can select BMP, JPG, PNG, and TIFF format. So this is a picture image 2 which I already put in the folder. So we open this image. For example, okay, we need to check first the image properties to get the size. Okay, this is about 371 KB. All right, then we select the image. Okay, so this is the size of the image. The uncompressed, the original image size will be shown here, 371.587 KB. Okay, then we can compress the picture. Once we press this button, the DCT technique will run, and it will take some time to compress the image. Okay, so now you can see the size of the image is compressed is 96.917 KB. So we can go back to the file to see the uncompressed. We can go back to the file to see the compressed size and the image. So this would be the compressed image. So we can see the size is 96.9 KB. Okay, and we can see the image quality here. So almost both images, this is the original image and this is the compressed image. Both the qualities are very good, and the difference is very small, almost cannot see with naked eye. And this would be the entire framework development for lossless image compression. That's all from us. Thank you.